So now we need to introduce the concept of heat and think about heat versus temperature, which are not the same thing. So what do we mean by heat? Let's use an example. Say we have some cold water in a saucepan and we want to cook some pasta. We need to raise the temperature of the water. How do we do this? We add something called heat. We put the saucepan on a hot stove and somehow heat is transferred from the stove to the water. And what's happening to the water molecules? Yes, they are increasing in temperature, and using our model of matter and the fact that temperature is proportional to the kinetic energy of the molecules, we can understand that the water molecules are moving faster as a result of adding heat. But what is actually being transferred? Well, let me tell you now that heat, which has the symbol Q, has the units of joules. You hopefully remember this from mechanics as being the unit associated with, yes, energy. So when you raise the temperature of the water to cook the pasta, we are adding energy in the form of heat to the water. Heat is the transfer of internal energy from one body to another. In my example, it is from the stove to the water. Heat always flows from a higher temperature object to a lower temperature object. Heat is internal energy on the move. And actually, once it stops moving, we stop having the need for the concept of heat. There is an analogy to having a separate concept for moving energy in mechanics. Can you remember what it might be? It is the concept of work, which is also energy in transit. So I've mentioned internal energy twice now without defining it, so let's define it now. Internal energy, which has the symbol U, is the total energy, the sum of the kinetic and the potential energies of a molecule that make up an object. U equals Ke, kinetic energy, plus Pe, potential energy. It also has the units of energy, joules, and it is not a temperature either. Kinetic energy is associated with the movement of the molecules, and Pe, the potential energy, is associated with the bonding between the molecules. Not surprisingly then, we can see that it's only the kinetic energy that is transferred in the form of heat. Physically, the heat transfer process occurs via microscopic elastic collisions that transfer the kinetic energy. So, some important points. Heat is not temperature. It is a form of energy, and it is internal energy on the move. We can see this by looking at the units. Thus, we can start to see that a body could have a very high temperature, but this does not mean it always has the capacity to transfer a large amount of heat. Getting back to our example, say now we have 2 saucepans of boiling water ready to cook pasta. The 2 saucepans have the same temperature, close to 100 degrees, but now we have twice the internal energy compared to if we only had 1 saucepan of boiling water. So the difference is that the temperature is not proportional to the mass of the object, but the internal energy, and hence the ability of an object to heat up another body, is dependent on the mass of the object.